Hello friends, I am Dr. Baljeet Kaur, and today we are going to discuss about Internet Protocol. As you know that network architecture that is consist of 5 layers, that is in TCP/IP layer. If we name the layers, application layer, transport layer, internet layer, um, host to network layer, and the physical layer. So the most important layer that is responsible for connecting source to the destination is our internet layer. So today we are going to discuss about the protocols that belong to the internet layer. So let us start with the internet protocol. So internet protocol is responsible for connecting source to the destination, and we know that whenever we have to send something to an appropriate destination, we need an address. So in terms of networks, an address is defined as an IP address, which is a unique address. So if we define as a connection oriented or a connection less service, so we can define that IP is a connection less service which is unreliable, fine, but it is as secure or as reliable as our post office service, which is also connectionless, but we know that our letters are obviously we are going to receive. IP accept data, whatever data is passed down to it from the upper layers, and it forwards to the data in the form of IP packets. All the nodes are identified using an IP address. Packets are delivered from the source to the destination using these IP addresses. Whenever you send an email, or either you make a video call to your friend, fine, the final destination is recognized as an IP address, and the data is sent from your machine to the destination machine on an particular IP address. As you can see in this particular diagram, there are, on one side we have an host machine X that is sending data to destination machine, say Y. While sending this data from machine X to Y, as you can see, there are multiple set of routers in between involved. You can see that the routers are labeled as A, B and C. The host machine and the destination machine consist of all the layers of OSI models, that is physical, data link, network, transport, session, presentation and application layer. These layers are available on both the host like X and on Y. But on the other side, when we talk about interconnecting machines, these are A, B and C, they are working on only 3 layers, that are physical, data and network layer. On the top of it, we can say that all connecting devices A, B, C work on third layer, that is network layer, because the network layer is responsible for connecting two machines. One is source and the other is destination machine. And the addressing, if how these machines are identified, they are identified based on the IP addresses. So IP addresses should be unique, fine, and IP version 4 is the unique addressing scheme by using which we can identify or we can locate machines over a network. So if we will explore more about IP address. So IP address is the first interface of an host. By using IP address is a means by which I can identify a machine. For example, if I have to call a student, we can call them by roll number 1, roll number 2. What are these? They are just an identity for a student. By using this identity, we can locate a particular student. In the same way, in a network environment, if we have to identify machines, we have to number them. So IP address is the way to identify a machine over the network. So there are, if generally a one machine carries one IP address and that is unique to it. If there are multiple interfaces for a machine, for example, if a machine is connected to multiple networks, It means it should have multiple identities for various networks. In that case, one machine can have multiple IP addresses. Can you give an example? In what are the machines that can have multiple addresses? So routers are the machines that try to connect they try to connect multiple networks together. So it means they are having multiple interfaces. So they can so routers can have multiple IP addresses. Generally, the IP address version, there are two IP address versions, address version 4 and IP address version 6. IP address version 4 was applicable in 1970. So it is a 32-bit IP address in dotted decimal notation. And for ease of reading, we can read it as a decimal notation, like as we can read as 193.140.195.66. So addresses can start from 0.0.0.0 to maximum to 255.255.255.255. But all the address values where network address and the host address, all bits are 0 or all bits are either 1, are not valid addresses. We will be studying that what is the special meaning for them in the next lectures, because generally all zeros means it's me itself, all ones means broadcast to everyone. So we will have a more detailed discussion over this in the next lecture. IP address is divided into a number, into a network number and a host number. For example, if you have to define your home address, you cannot say flat number 123 Goyal Ganga. So you have to specify the name of the city and the name of the state as well as the name of the country. Without it, the recognition is not complete. Even on the network also, you cannot name that machine number this, host number this. You have to specify what is the network number of that particular machine. So to specify a unique address, your 32-bit address is divided into two parts, network number and the host number. Now there could be different choices, that how many bits are used for can be used for network number and how many bits should be used for a host number. There are different possibilities that we are going to discuss in the next slide, and all the addresses, either it is network address or the host address, cannot be all zeros and 1 because they have some special meaning. Look at this diagram. In this diagram, you can see that 32 bits are used for network and host address specification. For example, you can see that 172.16.122.204 is the address. It is class B address, where 2 bytes are used for the networks and the 2 bytes are used for the host address. Now, what is the meaning of class B address? So let us have more discussion on the different types of classes. In this diagram, you can see that there are three classes, class A, class B and class C. These are the different addressing schemes. Actually, we have 5 addressing schemes in which IP version 4 can be divided. Class A, class B, class C, D and E also. Look at class A. Generally, by looking at very first byte of the network address, we can specify either it belongs to class A, B, C, D or E. If you look at the very first byte, if the leftmost bit in the first byte is 0, then it is class A address. And if you look at the first byte and the leftmost bit is class Z, if the leftmost bit is 0, then how many bits are remaining? Only 7 bits are remaining. So it means out of 8 bits, only 7 bits are used for network address and the rest of 3 bytes, it means 24 bits are used for host addressing. So how many network addresses can be generated? Because there are only 7 bits for network, so in total there are 2 raised to power 7. It means 128 network addresses can be generated. As I told you that not all the bits can be zeros in network. and the host, and not all the bits can be ones in the network and host address ID. Fine. The next class is class B. As you can look at the first byte for the class B, that if the leftmost two bits are 1 and 0, it means that class is class B. And in class B, 2 bytes are used for network and the 2 bytes are used for host address. So in all, we can say that 16 bits are for network and 16 bits are for host, but as 2-bit leftmost bits are prefixed like 1 and 0, it should be 1 and 0, they cannot take part in creating networks. So out of 16, only 14 are the effective bits that are used for creating a network ID. And again, the same principle applies here. Not all the network bits can be zeros and 1, and not all the host bits can be zeros, and all bits cannot be 1. That is again applicable here also. Now let us move to class C. Fine. In class C, 3 bytes are used for networks and only 1 byte is used for host ID generation. And if we look at the leftmost byte, that describes either it is class A, B or C. For class C, it should be the leftmost 3 bits should be 110. So as you can find out that out of 8 bits of the first byte, the 3 bits are already predefined. So here I am getting only rest of 5 bits and 2 bytes for the network ID. So in total, how many bits are available for network address? So it is 8 plus 8 plus 5, that is 21 bits are available for network generation. And how many networks can be generated by using class C? It is 2 raised to power 21. And how many hosts can be created by using class C is 2 raised to power 8. So if we look at the applications of these networks, so it is quite visible that class A is used where number of hosts are more and the number of networks are less. It is generally in a company environment where in a single company there are thousands of machines are connected through a network. Fine. So, and class C is used where number of hosts are less but the number of networks are very high. So the example scenario for class C are generally the home networks. You can find out in nowadays number of machines that are connected to network are very high, like every person is having either 1 or 2 mobile phones, a laptop with them, the even your TV is also connected to internet. On the other side, the hardware devices of home like an AC, a fridge, a washing machine, they all can be controlled through internet. It means all these devices also have an IP address. So there are almost different machines. There could be more than 5 or 6 machines over the in your home that are connected to network. Fine. So the number of hosts in this kind of network will not grow more than 20 or 50. So home networks can be connected through class C addressing scheme. So this slide gives you just a description of what we discussed in the previous slide. So class A address begins with bit 0. It has 8-bit network number. Fine. That ranges from 00000 to 127.1.255.255.255. So 7 effective bits for network ID and 24 effective bits for host ID number is there. And class B begins with 10, class C begins with 110, and class D begins with 110. And class E, that is identified by leftmost bits 11110, is unused, that is reserved for the future research purpose. Now, looking at an IP address, we could find out that an IP address is divided into network ID and the host ID. So, subnet mask is a way to define that how many bits are used for networking. So, generally, leftmost bits are used for network ID, and the remaining rightmost bits are used for host ID. So the number of subnet bits are generally identified as subnet mask. For example, right, class, let us take an example of class C address, say 192.168.2.0, because this range belongs to class C, and we know that in class C 3 bytes are used for network and only 1 byte is used for host. So if we have to create a subnet mask for this class, it means all the 3 bytes should be 1 and the one last byte should be all zeros. So the value would be 255.255.255.0. So the subnet mask for the following class, like 192.168.2.0, and with the subnet ID 15, it means some bits are reserved for extension, and it means 2 bits are reserved for extension. So the leftmost, if the leftmost 3 bits are used for extension, so I have the subnet mask will not be the default subnet mask. It means the subnetting concept is being used. We are going to study subnetting in the next lectures. So here it's not like that all the classes IP addresses will have the default subnet mask. As you can see here, the default the subnet mask can be 255.255.255.240. So if you want to configure the IP address, the subnet mask of your computer, you can go to Internet Protocol settings, and there you can do two things. You can define your static IP address, either you can define an DHCP IP address. When you select DHCP, then your computer automatically picks up an IP address from the range given by your network. On the other side, you can specify your IP address as 192.168.2.25. Now you can select the private IP address from class A, class B, or class C. Fine. Accordingly, you can specify the subnet mask. Fine. And the default gateway. Default gateway is the address of your router that is responsible for connecting your machine to the entire network. When a machine is connected over a network, fine, we define its IP address, but for the final communication, the MAC address of the machine is also required. So ARP is the protocol, address resolution protocol is the protocol that is used to identify the MAC address for a given IP address. Suppose the source machine, say 192.168.2.32, fine, sends a broadcasting message on its subnet asking who is 192.168.2.33. So the source machine wants to identify the MAC address of 192.168.2.33. So all the computers on the subnet will receive this request because it's a broadcast request, but the only destination, that is 192.68.2.33, will reply with its MAC address. So by using ARP protocol, the source machine identifies the MAC address of the destination machine. IP address 4 version IP version 4 has already been fully utilized, and all the IP addresses are finished in 1970s and has started showing its age. So it was most popular protocol used in the past, and it is still very popular, but it is not possible for connecting more number of machines by using IP version 4, because nowadays the number of personal devices that are having IP address are growing, like mobile phones, laptops, all the electronic devices are capable of having an IP address today. So the main issue surrounding IP version 4 is addressing. or the lack of addressing, because many experts believe that we are nearly out of 4 billion addresses available in IP version 4. So although this seems like a very large number of addresses, multiple large blocks are given to government agencies and large organizations. To name a few is like google.com, Mentra, Jabong, ICICI Bank, SBI Bank, all the commercial organization, even the government agencies are having their web portals, and they are having an URL to uniquely identify them, and they are by using domain name server, and IP version is you can say mapped to a URL address. So IP4 is not sufficient for today's requirement. IP6 is the solution for so many problems that we have with IP version 4. So IP version 4, as against with 32 bits in IP version 4, it has 128 bits addresses. IP6 addresses are being distributed and are supposed to be used based on the geographical location. So IP6 is the future, where by using which millions and billions of devices can be connected together. So in the future lectures, we will be discussing more about IP address classes and the subnetting concept. Thank you.